Hi, good day to everybody. It's Molly's Maths again, 12th of January. You know the routine by now. Let's get the music on. Let's hopefully, is it going to be something loud, something soft, or something nice and smooth, soothing? Get the music on and we'll get on with Molly's Maths. Let's move on to question one. I think going to be quite challenging, some of the questions today. Right, question one. Um, this is really about a dice. I mean, normal dice, you have six numbers on a normal dice, but for this question, we've got a 10-sided dice with numbers of 1 to 10 is rolled. So, what is the probability of a free, rolling a free? So, basically, if you've got 10 numbers, you've got 10 different numbers, probability of getting a free is well, there's only one free on the dice, so it'd be one in. The answer to that is it's going to be 1/10. 10 different options, and you've only got one chance of getting a free. So there's your answer. So, second part of the question is, what is the probability of getting a number less than 4? So, how many numbers on a 10-sided dice are less than 4? 1, 2, 3, 4 is more. All the rest are bigger than 4 or more. So there's only three numbers that you can get less than 4. So again, it'll be 3/10 because you've only got three chances of getting. Well, you can only get numbers 1, 2, and 3. So there's only three numbers, and there's 10 in total. So what's the probability of getting a squared number? Now this is a bit more. Do you know your squared numbers? A number that you times um, is a squared number is a number that can be have a square root that will give you an integer. So, well, let's have a look at the squared number options. So 1 times 1 equals 1. So that's a square. So 1's a squared number. 2 times 2 equals 4. Another squared number. 3 times 3 equals 9. So you've got three squared numbers, because if you do 4 times 4, that will be 16. It won't be on the dice, will it? So you've got three squared numbers on the dice. So, and how many different numbers are there on the dice? We've got 10 numbers on the dice. So the chances of getting a squared number are again 3/10. So there you go. There's a bit of probability for you, and I hope the probability that you're listening to some good music is helping you with the maths. Let's move on to question two. Right, solve 3a plus 2c. And we've been given the values of a and c. So basically, we've got 3a. So an a equals 4. So that would be 3 times 4, as we're replacing the a with a 4, plus 2. And what is c? Is 2 times minus 2. Okay, so we've got two terms there, or two. So let's 3 times 4. What do you make 3 times 4? I think I'm going to go for a 12. Plus 2 times minus 2. What happens when you times something by a minus number? If one's a positive and one's a minus, it becomes a minus. So 2 times 2, it's minus 4. So 12 plus minus 4. So basically it's 12. Basically that's just 12. we write it down, it's 12 minus 4. And what does that equal? 8. So again, all you do, if you're asked to solve something like that, and you're given the values of A and C, you just put them in and you work through it. It's not too difficult. So let's have a look and see what the next question is. So question 3. Oh, this is like a Christmas cracker one. You know, somebody might ask you this from a Christmas cracker. Max thinks of a number. He squares it. Then he adds 4. His answer is 53. Ooh, well, then you've got to think of all this in your head. What was the number he thought of? Well, there's a way. All you have to do is reverse it all. So basically, what we need to do really is just reverse it all into so basically we're going to reverse it all. So he thinks of a number, so we'll call the number x. So he thinks of x, so we'll put down x, and what does he do? He squares it, so we'll make x squared, and he adds 4, so he adds 4, and that equals 53. So you've got like an equation there, haven't you? So how do we solve it? We have to get x on its own, really, to solve the equation. So what we can do, the first thing we can do, we'll take 4 away from this side of the equation. So that'd be 53. Whatever we do to one side, we have to do to the other. So if we're taking 4 away from there, we have to take 4 away from the other side. So then we've got x squared equals 53 minus 4. What's 53 minus 4? 49. So x squared equals 49, but we don't want x squared, do we? So what's the opposite of squared? It's the square root, isn't it? So x equals the square root of 49. And this is where you need to know your times tables. So so 6 times 6 is 36. What's 7 times 7? 7 times 7 equals 49. So the answer here is the square root of 49 is, if I'll get my pen working, the pen's playing up a bit here, is 7. So the number Max thought of it to start with was 7, because he thought of 7, he squared it, which made it 49, then he added 4, which made his answer 53. So, but we've reversed engineered it, and do you think you could do that again? Maybe set yourself another little task at home, and maybe do something with a square, or maybe add a different number. You can experiment to do that. Let's move on to question 4. Question 4. Ooh, it's the old circles again. So circles, we've got two questions. We've got 2 circles here, and on the first circle we've got to draw a radius. Well, the radius is just a line that goes from the centre point of the circle to the circumference. So I'm just going to, it would be a straight line, but in my case my pen's not that brilliant, but there you go. that would be a radius. So I'd call that the radius. And the chord is slightly different. All you have to do, you can draw a point from any two places on the circumference. So one place on the circumference to another place. It's got to be a straight line, and that's what we call a chord. So I could draw a line from there to there, and that would be a chord. So that's your chord, and that's your circumference. Again, something to look at, circles and how they work, and maybe, yeah. So let's just write chord in there to make it. That's your chord. Not a music chord, but a chord in a circle. Factorise, right, these can be quite challenging. I'm going to try and explain it, but I think you need to go into more depth to learn about factorisation. I mean, what we want to do is get a common, highest common factor outside the brackets and everything else inside the brackets. So basically, we look at both terms. So 3y and 15. What is a common factor of 3y and 15? We've got 3, and we got 3, and 15. A factor of 15 is 3. So what we can do is we could do this. So the highest common factor equals 3 in this case. So we're going to put the 3 outside the brackets. But what are we going to put in the brackets? Well, you would have, so that would equal, so let's just do this here. 3y divided by 3 equals, you're left with y. And 15 divided by 3 is 5. So inside the brackets you would have y plus 5. So that's factorisation. We factorise the first one. And let's go for the second one. What is the highest common factor of 2a? So let's write it over here on the side here. Highest common factor of both those statements equals. So what have we got in both sides? We've got a squared, so we've got an a, and 3a, we've got an a there as well. So the highest common factor has got to be a. So we're going to put a outside the brackets. So what's going to go inside the brackets? So let's just work that out again. So a squared divided by a gives you a. And the other one is, the other term is 3a, and if we divide that by a, what are we left with? 3a divided by a equals 3. So inside the brackets, we got a plus 3. Quite a tricky question. Factorising is quite a challenge, but I mean, I think you can invest some time in it and have a look at it. I mean, I've tried to explain it, but I think you need to have a look at it a bit more and get to grips with it and find which way works best for you. But you know, it's basically the highest common factor of all the terms in what you're given, and then you use that to put that outside the brackets, and then you work out what's inside the brackets by dividing by the highest common factor. Yeah, so that's it really for today. No more questions. How's the music? Have you got the volume up on full blast so you're not listening to the maths, or you're really listening to the maths? Well, anyway, that's it for today, and we'll see you again soon for another exciting Molly's Maths. Goodbye from me.